Okay, hi Math 113. So we're back looking at the second part of what we've talked about with division this week. So what I asked everybody to do in Wednesday's class was to start out in groups. We talked about, let's say you have 260 pencils, and you want to put them into groups of 12. How many groups can you have? And often we would think about dividing, right? Either dividing in our calculator or dividing on paper, doing long division. But I asked everyone today to come up with this idea of how many groups can you make without using any division, okay? So I gave them a few minutes to think about it. I would like you to think about it also, to take a couple minutes, pause the video, and especially think about, if you're teaching younger students, even very young, this idea, maybe not quite as large numbers, but how could we figure out how many groups we can make, okay? So go ahead and think about that for a minute, and then we'll talk about it when you start the video up again. Okay, so we have talked in the past about how multiplication is repeated addition. So if I have 8 plus 8 plus 8 plus 8, that's the same as 4 times 8, right? 4 groups of 8. Well, the same idea is, a similar idea holds true for division. So if I have, this big basket of 40 stickers, and I want to give each child 5 stickers, and I want to know how many children I can give stickers to, essentially what I'm doing is I'm taking out groups of 5 until I don't have any stickers left, right? I'm taking out one group of 5 and another group of 5 and another group of 5. I'm subtracting continuously. And once I do that over and over and over, then that's division, right? When I figure out how many groups of 5 can I take out before I run out, that's going to be division. So hopefully you kind of, thought about something like this when you're thinking about how to do this. And there's not just one right way of how to do this. But some of the groups in class today, I don't know if I'll remember exactly how they did it, but they did something like this. They said, okay, what if we have 10 groups of 12? Well, that would take up 120 pencils. Okay, so that's a chunk of them, but that's not all. We still can do more. So can we do another 10 groups of 12? Well, another 10 groups would be another 120 pencils. So altogether now, we've used 240 pencils. Can they do another 10 groups? No, because that would be 360. That would be way more than we have. We only have 260. So you might at this point kind of think, okay, I have 20 pencils left. How did I get that? Well, 260 minus 240. So I have 20 pencils left. So can I get one more group of 12? Well, that would be 12 pencils. So altogether now, I would have used up 252. Can I get another group of 12? Well, if I tried to get another group of 12, that would give me 264, which is too many. So I couldn't do that. So I don't have enough to do another group. So I have 252 pencils that I've used up. The question is how many groups? Well, if we look over here, first we took 10 groups, and then we took another 10 groups, and then we took one group. So altogether we have 21 groups of 12, which equals 252 pencils. And then I also have 8 pencils left over, right? So I didn't use all my 260, but I couldn't make another full group of 12. So in this situation, and this is a common way, I see even my students at TC3 who sometimes are not as comfortable with division, they'll kind of work up to it like this. Okay, so this would be a good way, if you're working with students who are much younger than the level where you have division, again, let's say, you're working with toys or whatever you're going to distribute. It can be a much smaller number, but you can kind of get the idea that, okay, we need 5, blocks in a group. Well, how many groups of 5 can I make from this group of 27 blocks or something? Okay. So we talked about that. And so we then are also going to talk about the standard division algorithm, kind of what's happening. And then we'll look at another type of algorithm, of division algorithm, that kind of shows us the place values a little more easily, kind of similar to how the partial products method for multiplying showed us those place values more easily. So let's go ahead and divide 4,581 divided by 7. We're just going to do it the normal way, first of all. So just kind of think about our division. So 7, we say, can't go into 4. 4 is not big enough to hold any 7s. So I look next to one more place value. So I say 7's going into 45, and I say it goes in 6 times. So 7 times 6 is going to be 42. So 5 minus 2 is 3, and then I bring down the next number. Now, once I've put a number up there, multiplied to get my 42, subtracted and bring down, I've done one whole cycle. Everything else beyond this is just a repeat of that cycle. So 6 times 7, that's what gave us our 42, right? We subtracted, we bring down. Now we're seeing how many times 7 can go into 38 without going over. So we know that's going to be 5 times, because 7 times 5 is 35. I subtract and get a 3. Now if you ever subtract and this number is larger than this, it means that you could have put another group in. So you need to change what you have up there. Then I bring this down, and I see how many times 7 goes into 31. It goes in 4 times, which is 28. So I have 3 left over. Okay. So it's 654 with a remainder of 3. Or 654 and 3/7, 3 out of 7 parts of another group. Okay, so now let's look at this method that's called scaffolding method. And I was also telling the students in the Zoom meeting today that over the years when I've had students who are international students or learned long division in another country, often it's written in the opposite order. So I can't exactly replicate it, but I can follow it when I see it. It's sort of written like this, and it comes down instead of, we kind of put our answers up here. Okay, so if you're teaching international children at any point, or children who did live in another country at some point, then you may see that. Okay. So this new method is called the scaffolding method. And I told the students in the class, in the Zoom class today, that it's a little tricky to follow. I'm not going to ask you to recreate it, but I just want you to kind of see it and be aware of it and what the pro is versus this way. So when we are doing the standard division algorithm, just like with the standard multiplication algorithm, sometimes the trouble can be that we're not really thinking about the place values. So I'm saying, well, 7 can't go into 4, but it can go into 45. But that's not really a 45, it's 4,500. And this is saying 7 goes into 4,500 600 times. So the scaffolding method kind of brings that out a little bit and reminds us of those place values. So I'm going to start with the same problem, 4,581 divided by 7. So what I'm going to ask myself at each step is basically how many of whatever place value I'm on. So first, I want to know how many thousands can I put in here, or how many, I shouldn't say how many. Really what I want to say is how many groups of 7 times 1,000. Well, I can't put any groups of 7 times 1,000 because 7 times 1,000 is 7,000 and that's too big. Which really is what I'm saying when I say, can 7 go into 4? Okay? So I can't do that. So then, just like before, I look at 45. So I can't put any thousands in there. How many groups of 7 times 100? Well, I'm looking at this 45 and really thinking about it being 4,500. So I could put 6 groups, okay? So because 700 times 6 would be 4,200. So I'm thinking about this, the fact that this right here is a place value, okay? It's in the place value, it's not just a 6 floating in the air. So then I subtract, so I'm actually going to put 600 up here in this scaffolding method. Okay, so I'm going to take 4,200 now. I'm going to subtract, and I get 381. Okay, and then now I'm going to say 7 times how many groups of 10? I did my hundreds. Well, so 7, because now even 7 times 100 is too many, so I'm going to go down to tens. Well, 7 can go into 381. I can have 5 groups of 10. I can have 7 times 50. So I can put 50 up here, because 7 times 50 is 350. Subtract, I get 31. Now I'm doing 7 times ones. Okay. I can have 4 there. 7 times 4 is 28. These then combine, just like before, to make 654. Okay, to me, again, the partial products algorithm, like multiplying, is much easier to follow. That's why I'm not going to ask you to recreate this. But hopefully you can see how, again, it just takes the numbers and really thinks about the place value. It's not just a 6 and a 42, it's 600 and 4,200. But because there would be zeros there, we just bring down the other number, right? Here, we don't have to just abstractly bring down a number because there are zeros and because there are zeros. So it just takes some of that sort of magic out of it, right? Instead of just, randomly bring down this number, we can see why. So I won't ask you to recreate this, but I did want to just mention it there. Okay. The last thing I wanted to talk about was just division a little bit with fractions, real fast. So just wanted to point out, okay, let's say that I have, this might not have been the same exact example I used in class today, but let's say I have 3 cookies and I want to split them among 4 people. Okay, so I'm going to take 3 cookies and divide them into 4 among 4 people. Well, again, the easiest way to do that is to divide each cookie individually. So if I have my 4 people, everybody gets 1 equal share of each cookie. So person 1, for example, or any of these people get 3 parts. Each part is 1/4 of the total. So they each get 3/4, right? 1/4 plus 1/4 plus 1/4. Well, we always kind of know if we have 3 divided by 4, we know this fraction bar means to divide. But here's kind of showing how they really are related. Okay, that when I divide, I really do get that fraction of a whole thing. All right, so this is where we're going to stop for now. Make sure you read the to-do list. There is a test the end of this week. It's actually going to be available tomorrow, and it will be due Sunday night. It will be in Blackboard. It'll be up. There's already a list of topics that could be up there, but the test is open book, open notes. You can look at the videos. You just can't use any other resources. Okay? As always, please let me know if you have any questions. Thanks.